All right, now that we know how to find missing terms in the sequence, we want to find the number of terms. So I've given you the first two and the last. Now, traditionally speaking, you should have already learned how to do logarithms, and so then we would identify the pieces we know from the explicit formula, substitute all the known pieces into the formula and solve. So I'm going to show you what that looks like. We know that our explicit formula is term n equals term 1 times r to the n minus 1 power. So we know that term 1 is 2, we know that term n is 128, and we know that r is 2 because to get from 2 to 4 we have to multiply by 2. So we put that in, we get 128 equals 2 times 2 to the n minus 1 power. We would divide both sides by 2 to get rid of this 2 out front, and we get 64 equals 2 to the n minus 1 power. And there's a lot of different ways you could go from here, none of which are real fast. But basically speaking, we don't know how to deal with the n minus 1 power. And there's a couple ways I could show you, but most of you would probably be way over your head, and it's not worth getting into. So what we're going to do is we're going to go old school. We're going to say we know that we have 2, we have 4, and we have some number of terms, and then we have 128. We're going to find those terms. We know that 2 times 2 is 4, so 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128. Then we're going to count them up. 1, 2, 3, 4, 5, 6, 7. Therefore, n, which is our number of terms, is 7. Not too difficult. And I promise you I will not make these be where n is like 65. I think the biggest I might make would be maybe 10 or 12. And then we've got word problems. So we have the value of a car depreciating by 4% each year. We have Alan who bought a car for $39,500. Find the value of the car for each of the first 3 years, and then determine the car value after 11 years. So the first thing we need to do is set up our sequence. But in order to set up the sequence, it makes it easier if we write that explicit formula. Here's the thing. We could use our traditional t sub n equals t sub 1 times r to the n minus 1, except that if you think about it, 39,500 isn't truly term 1, because that would be when you would have, it's really, I guess you could say it's term 1, but it's more like a term 0 because you've had no depreciation. So it's easier in this respect to look in terms of y equals a times b to the x, which is our original exponential formula, since geometric sequences are exponential. It just makes your life a lot easier, since you only have to deal with a start value and a change and things like that. So we know that a is 39,500. Our b is going to be taking this 4%, changing it to a decimal of 0.04, and because we're depreciating, we're taking 1 minus 0.04, so our b value is 0.96. So which means that each year our car will retain 96% of its original value. And then we have x as x, that's our time in years. So we need to find, we know our term 0, or our starting value is 39,500. So we want to find after 1 year. So we will take that 39,500 times 0.96 to the first power. And when we do that, we get $37,920. And then to find the second year, we're going to take our original 39,500 times 0.96 to the second power. Yes, you could also take your $37,920 times 0.96 again, which we're going to get to in a minute. So you get $36,403 and 20 cents. by the way. You have to use the explicit formula to solve a problem, which is what we're doing. Then term 3 equals 39,500 times 0.96 to the third power, which gives you a value of $34,947.07. I actually had to round that because it was 3 decimal places. Now, before we find that 11 years, I want you to also think about this before I write all over it. What would you do if you were asked to write a recursive formula? That's what I was talking about. You could, each time, take what you got and multiply it by 0.96 each time, which in that case, it would be term 1. We're going to call it term 1, 39,500. And term n is going to be 0.96, which is our rate, times t sub n minus 1, so the previous term. So now that we've talked about that, let's go back and let's find term 11. So that's going to be our 39,500 starting value times 0.96 to the 11th power. And when we calculate that out in the calculator, we get a price of $25,210.45. Okay, so that's what we're doing today. A little bit of word problems, a little bit of finding the number of terms. And so here are your 2 problems. The first one, finding the number of terms in this sequence. And then to save for Kelly's college education, her parents put $1,000 into a savings account when she was born in 1993. And then every year thereafter, the McBride family deposited 10% more than the previous year. In 2011, it's time to go to college. How much money did they deposit in 2011? Not how much money is in the account, but just how much money did they deposit. And as always, bring your questions with you to class.